Hello, fifth graders. It is time for lesson 3, powers of 10. So you need your uniform math packet out, and we're open up to page 3. We're going to look at pages 3 and 4 today. We get to look at some exponents today. You're going to feel so fancy and grown up. Expressions with repeated factors can be written by using a base with an exponent. And I think those might be new words. And the base is a number that's used as a repeated factor. So repeated means you over and over again, and factors are numbers you multiply. The exponent is the number of times the base is used as a factor. When you represent a number using a base and an exponent, you are using exponential form. So right here I have 1,000, and 1,000 we discussed previously is equal to 10 times 10 times 10. So you can see that I have a repeated factor, right? This 10 right here, I would call a repeated factor because it's the same number and it's being multiplied repeatedly over and over and over again, right? So the base is that number that I'm using as a repeated factor. So this 10 right here, this is called the base. That's whatever number is being repeatedly multiplied. This 3 right here, this is called my exponent. Yes, you should write this. I know you always want to know. The exponent tells me how many of the factor, the repeated factor, I am multiplying. So see how we have 1, 2, 3 tens that are being repeatedly multiplied? That's why that exponent is 3. So the exponential form of 10 times 10 times 10, or 1,000, would be this, my base and my exponent. And we have to know how to say that, right? We don't say 10, cute little 3. Wouldn't that be nice? No, we don't say that. We would say 10, so you can say your base, 10 to the, and these are called powers. So because it's a 3, we can say 10 to the third power. If this was a 4, we'd say 10 to the fourth power. If it was a 5, we'd say 10 to the fifth power. One thing that's special, like if your exponent's a 2 or a 3, they have special names. If this was a 2, I could say 10 squared or 10 to the second power. Because it's a 3, I could actually say, you can just put this in parentheses, 10 cubed. And when we get to our volume and surface area chapter, or volume and area, we'll talk about the fact that when you're finding volume, you're taking length times width times height. And that's usually what you do to find the volume of a cube. That's how it got its special name, but we don't have to know that right now. But 10 to the third power is fine. You'll also hear that said as 10 cubed. So the first part of what I want you to be able to do today is just to be able to write each exponential expression as a repeated multiplication and then solve it. And of course, we'll be looking for some patterns shortly here. So when you see 10 to the second power, or 10 squared, this means the repeated multiplication, 10 times 10. This means that my base 10 is being repeated twice, 10 times 10. And 10 times 10, well, you can just multiply your non-zero digits. 1 times 1 is 1, and we have those 2 zeros. That's what we learned in our first lesson. So 10 times 10 is 100. All right, in 10 to the fifth power, how many tens am I multiplying? I'm multiplying 5 tens. Common mistake is thinking that this means 10 times 5. It doesn't. In an exponential expression, we have a repeated factor. If you do 10 times 5, there's nothing repeated. 10 to the fifth power means that you are multiplying the number 10. You have 5 of those tens. So we are repeatedly multiplying 10 5 times. 1, 2, 3, 4, 5. And 10 times 10 times 10 times 10 times 10. What is that? Well, if we multiply our non-zero digits, 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is, yes, 1. When you repeatedly multiply 1, nothing's going to change, is it? And then we see we have 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5 zeros. And let's put in our comma. Sorry. So 10 to the fifth power is 100,000. 10 to the fourth power, that means that I am going to have 4 tens that are being multiplied. That is not 40. 10 plus 10 plus 10 plus 10 is 40. But exponents show repeated multiplication, not repeated addition. So the answer to this, 1 times 1 is 1. times 1 is 1, times 1 is 1. And there are 1, 2, 3, 4 zeros. 1, 2, 3, 4. I put in my comma, 1, 2, 3. So 10 to the 4th power would be 10,000. And 10 to the 1st power, how many 10s do we have? 1. It's just 10. Kind of a trick question, I guess. Okay, so basically if you wanted to write this out, the base, that tells you the number that's being repeatedly multiplied, and the exponent tells you how many of them. So there are 2 10s that are being multiplied. 10 times 10 is not 20. 10 times 2 is 20. 10 times 10 is 100. Okay, the next set, I want you to use an exponent to write each repeated multiplication, and you don't have to solve it. So basically, I want you to go from this form to exponential form. And when doing this, you can only express the numbers that are repeatedly multiplied using an exponent. So when I look at this, I don't see any 5s repeated. So I'm going to rewrite my 5 and multiply that by, okay, now we can change this into an exponential expression because I am repeatedly multiplying 10. So the number that I'm repeatedly multiplying, that's my base. The number of times that I see it, that's my exponent. So I would want you to write 5 times 10 squared. Okay, sorry for all the creaking noises. I am downstairs. I have to be away from everyone, obviously. So I'm in my basement. So I'm sorry for the shadows and the darkness. Doing my best here. Okay, my husband apparently is doing something outside that is making a lot of noise. I don't know if you can hear it, but I sure can. Okay, so this one, do you see how there's just 1 3 right here? That's not a repeated factor, so I'm just going to write my 3. I'm going to write all these repeated 10s as an exponential expression. So 3 times 10 times 10 times 10 times 10 times 10 is the same as 3 times. Now, the base that's being repeated, the number that I'm repeatedly multiplying is 10. So that's the number I write. And how many 10s are there that are being multiplied? 1, 2, 3, 4, 5. So this would be the same as 3 times 10 to the 5th power. All right, if you wanted to, you could pause now and try to rewrite some of these on your own, but just make sure you press play in between each one because I wouldn't want you to do all 4 examples the wrong way. I'd want you to catch your errors as you go. So feel free to pause in between and try these out on your own. All right, for letter G, 9's not being repeated, so I'm just going to multiply or write the 9 times. I see that I'm repeatedly multiplying 10 3 times, so this would be the same as 9 times 10 to the 3rd power. Here, how do I write this as an exponent? Well, as a power of 10, I can write 2 times 10 to the 1st power. 10 to the 1st power is the same as 10. I know this one's a little weird, but I want to make sure that I always give you the examples that are a little weird, so when you see them, they're not weird. All right, next one. I see that 7's not being repeated, so I'm not going to put an exponent after that. I want to rewrite my 10 as a power of 10 because it's like to the 3rd power, to the 5th power, so it's called a power of 10. How many 10s are there? 1, 2, 3, 4, 5, 6, 7, 8. So 7 times 10 to the 8th power. And last but not least, I have this 1 by itself. I want to write this as a power of 10. This number 10 is being repeatedly multiplied, so that's my base. And how many? 2. So 1 times 10 squared. All right, turn your page, please. I'm going to keep talking about this exponent stuff. So multiplying a whole number by a power of 10. That's like another main topic. 0 patterns in exponential expressions, and exponential expressions are just like that base with the little tiny number, the base and exponent. 0 patterns in exponential expressions with a base of 10. That means the big number in the exponential expression is a 10. Can help us to quickly find the value of expressions. So we're going to do what we usually do, and we're going to look for patterns to help us solve problems faster. So when you have 10 times 10 times 10, first thing I'd like you to do, write this as an exponential expression. So 10 is the number I'm repeatedly multiplying, and the number of 10s I have is 3. So what is 10 times 10 times 10? Well, 1 times 1 times 1 is 1, and there are 1, 2, 3 zeros. This is not 30. This isn't 10 times 3. It's 10 times 10 times 10. So 10 to the 3rd power is 1,000. If you have 4 10s that are being multiplied, that would be 10 to the 4th power. And 1 times 1 times 1 times 1 is 1. And there are 1, 2, 3, 4 zeros. And I'm going to put in my comma. So 10 to the 4th power is 10,000. Here I have 1, 2, 3, 4, 5 10s. So this would be 10 to the 5th power. Again, not 50. This means I'm multiplying 10 repeatedly. That's not the same as doing 10 plus 10 plus 10 plus 10 plus 10. So 1 times 1 is 1, times 1 is 1, times 1 is 1, times 1 is 1. Yep, true. And we have 1, 2, 3, 4, 5 zeros. So when I put my comma in, 1, 2, 3, we have 100,000. So here's what I would like you to do. I'd like you to look at this because we're going to answer the question when evaluating base 10 expressions, and this right here was the evaluating. When you're getting the answer to a base 10 expression, meaning an expression that has a base of 10 with an exponent on it, the exponent is the blank as the number of zeros after the 1. So notice, every single one of these base 10s, they start with the number 1, don't they? That's because when you repeatedly multiply 1, it doesn't change, right? 1 times 1 is going to be 1 no matter what. All right, so I want you to pause this, and I want you to see if you can figure out a pattern with how many zeros you see after that 1. Press pause, press play when you think you've come up with a pattern. All right, welcome back. I am wondering if you noticed that all of these start with 1, right? And here there are 3 zeros, and my exponent is 3. Here, there are 4 zeros after the 1, and my exponent's 4. Here, there are 5 zeros after the 1, and my exponent is 5. So what's the shortcut way to evaluate 10 to the 3rd power? When evaluating base 10 expressions, the exponent is the same as the number of zeros after the 1. Okay, so that means if I gave you, and yes, write this, if I gave you 10 to the 7th power, instead of writing out 10 being multiplied 7 times, and this is not 70, okay, I keep saying that because that's a real common error that I see. This means I'm multiplying 10 7 times, not doing 10 times 7. Instead of writing all that out, I can say, oh, this is a this is a base 10. That means I'm going to have a 1 here because I'm repeatedly multiplying the 1. And how many zeros am I going to have after that 1? 7. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 1, 2, 3. We get 10 million. So this works when you have base 10 expressions, meaning your base, that number that's being raised to the power, is 10. And it works every single time. So we can use that to help us evaluate the rest of these problems here. Take a look. I have 75 times 10 to the 2nd power. Now, 10 to the 2nd power is the same thing as a 1 with 2 zeros, right? So it's like I'm taking 75 times 100. What we can do is we can multiply our non-zero digits. So if you see that you're multiplying a number by a power of 10, meaning your base is 10, you can just multiply the digit by 1. 75 times 1 is 75, and use the exponent to tell you how many zeros you would have after that. So 7,500 is what you would have. And again, the reason this works, I'm going to rewrite it over here, and yes, please write it. If you have 75 times 10 squared, that's the same thing as saying 75 times 10 times 10, right? To solve this, you would multiply your non-zero digits. 75 times 1 is 75, and 75 times 1 is 75. So when you multiply the 75 by that 1 twice, you'd get 75, and how many zeros are there? 2. It works every time. So for this one, it would look the same, except I'd have 3 10s. That means I would be doing 75 times 1 times 1 times 1, which is going to give me 75, except now I'd have 3 zeros that I ignored, so 75,000. If you have 75 times 10 to the 4th, that means I would have 75 times this 1 4 times, which would give me 75, and I would have 4 zeros to get 750,000. So let's use that to help us with the rest of these. And again, once you feel confident with it, press pause between each one and then press play to see if you are correct. Okay, sorry. I have to blow my nose. My apologies. Okay, so 43 times 10 to the third power. I notice this is a base 10. So I'm going to do 43 times 1, which is 43. And this 3 right here tells me I would have 1, 2, 3 zeros. And again, the reason this works is because this is like saying 43 times 10 3 times. That would mean I do 43 times 1 times 1 times 1, which doesn't change the 43. And how many zeros did we ignore? 3, which is the same as that exponent. 5 times 10 to the 6th. I can do 5 times 1 because I would be doing 5 times this 1 6 times, and it's not going to change that 5. It's still a 5. And how many zeros am I going to have in this problem? 6. 1, 2, 3, 4, 5, 6. So let's put those in. So 5 million. 126 times 10 squared. You might think, I can't do that. You can. You can do 126 times 1, right? This is like saying 126 times 10 times 10. And when you do 126 times 1, that's 126. Times another one, that's 126. And how many zeros are there? 2. So 1, 2. So 12,600. All right, 10 times 10 to the third, there's a couple different ways to look at this. You could just look at this as 10 times 1, which is 10. And then I have 3 zeros, 1, 2, 3. You might also look at this as, I'm going to write it off to the side, 10 times 10 to the third, as 1 times 1, which would be 1. And then we'd have 3 zeros here and another one there, 1, 2, 3, 4. Either way, it's 10,000. Okay, for these two here, I have some parentheses. In the very beginning of the year, we talked about order of operations. And hopefully you recall that we are always supposed to solve what's inside parentheses first. Then exponents, right? That was the P and then E, parentheses, then exponents. So for this, all you need to do is multiply what's inside. 3 times 4 would be 12. And then you have a problem just like the rest. This would be 12 times 10 to the 4th power. So you can do your 12 times the 1, which is 12. And this 4 means I would have 1, 2, 3, 4 zeros. So 120,000. And last one, 7 times 8 is 56. And if you have 56 times 10 to the 5th power, I can do 56 times 1 is 56. And then this means I would have that 10 5 times, so I'd have 5 zeros. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. 5,600,000. Hopefully you're quite excited by how much you have learned today. I appreciate you working hard, and I still miss you guys very much. Hopefully I'll see you soon.